Greetings, friends. I am Zaid. I welcome you to the channel, and I hope you are all doing well, safe, and in peace. Today we talk about something mysterious, scientific, and full of curiosity. It is called a fast radio burst, often shortened to FRB. So what is it? How did scientists discover it? Why does it fascinate both astronomers and ordinary people like us? Let us start from the beginning. In the year 2007, a graduate student named David Narkovich was studying archival data collected by the Parkes Radio Telescope in Australia. He was not looking for anything unusual. He was simply analyzing pulsar survey data. But then he noticed something extraordinary, a short, intense burst of radio waves that lasted only a few milliseconds, a fraction of the blink of an eye. The burst was so powerful, it seemed to release as much energy as the sun emits in a single day, but compressed into less than 1,000th of a second. At first, many scientists thought it might be interference from earthly sources, maybe satellites or human-made signals. But then, more of these bursts were detected in different locations across the sky. They came from outside our galaxy. They were real, and they were cosmic. Since then, scientists have catalogued hundreds of these bursts. Some appear once, never to be seen again. Others repeat at irregular intervals. The repeating one give astronomers clues about where they might come from. Most theories point to exotic cosmic objects, like magnetars, which are neutron stars with extremely strong magnetic fields. When they flare, they might send out bursts of energy detectable as radio waves across space. Other ideas suggest that collisions of neutron stars, black hole activity, or even plasma interactions in extreme cosmic environments could explain them. But despite many studies, the mystery is not fully solved. Each discovery adds to our knowledge and also to our curiosity. Before we move further, I want to make something clear. Before we move to our today, I want to say that this channel is user-friendly. No offensive content, no misinformation. We explain things with respect, curiosity, and authenticity. So with that assurance, let us continue to explore the fascinating world of fast radio bursts. Now that we know how fast radio bursts were discovered, let us dive deeper into their strange behavior. One of the most surprising things about FRBs is how far they travel. These bursts are not local. They are not from within our own solar system or even just the Milky Way. When scientists measured the dispersion of the signals, they realized something powerful. The radio waves were stretched out. Lower frequencies arrived later than higher ones. This effect is called dispersion measure. It shows us how much matter the signal passed through. From this, astronomers concluded that many FRBs come from billions of light years away. Imagine this: a signal that lasted less than 1,000th of a second traveled across the vast universe through cosmic dust, plasma, and galaxies before reaching Earth. That alone makes FRBs a unique tool in astronomy. They do not only puzzle scientists, they also help map the invisible structure of the universe. You see, between galaxies lies a web of diffuse matter known as the intergalactic medium. It is faint and difficult to study, but FRBs, with their dispersion effect, allow scientists to probe this hidden web. In 2020, a breakthrough happened. For the first time, a far radio burst was traced to its host galaxy. It came from a spiral galaxy located about 500 million light-years away. Using high-resolution telescopes, astronomers narrowed it down to a region within that galaxy, proving that FRBs can be localized, not just detected. This was a major step forward. It shifted FRBs from mysterious phenomena to practical cosmic tools. Yet the repeating FRBs make things even more interesting. Some repeat every few days, others in strange cycles. One burst, named FRB 12102, is famous for its repetition. It comes from a dwarf galaxy with a powerful source of magnetic activity. Why does it repeat? Does it mean that different FRBs have different origins? These are the questions that scientists continue to explore. Even though FRBs are very short, they carry massive amounts of information. Each signal is like a fingerprint from the universe. And with every new detection, we move one step closer to unlocking the mysteries of the cosmos. As we continue exploring the mystery of fast radio bursts, let us look closer at the possible sources and the technologies used to study them. One strong candidate is the magnetar. A magnetar is a type of neutron star, a collapsed core of a massive star with a diameter of just about 20 kilometers. But within that tiny sphere, it contains more mass than our Sun. Its magnetic field is trillions of times stronger than Earth's magnetic field. When its magnetic surface cracks or shifts, it can release bursts of radiation. In 2020, for the very first time, astronomers detected an FRB originating from within our own galaxy, the Milky Way. It was traced back to a magnetar named SGR 1935-2154. This discovery confirmed that at least some FRBs can be created by magnetars. But here is where it gets complex. Not every FRB looks the same. Some are one-time bursts. Others repeat. Some are incredibly bright. Others are weaker. This variation suggests that FRBs may have more than one source. Other possible origins include collisions of neutron stars, black holes feeding on matter, shock waves in dense plasma, or even phenomena we have not yet discovered. To catch these signals, astronomers rely on large radio telescopes. One of the most important tools is the Canadian Hydrogen Intensity Mapping Experiment, better known as CHIME. It is a unique telescope in Canada that has detected hundreds of FRBs since it began operation. Its wide field of view and constant sky monitoring make it perfect for spotting these short, unpredictable events. Another facility, the Australian Square Kilometre Array Pathfinder, or ASCAP, has also played a key role by pinpointing FRB locations with great precision. And soon, the Square Kilometre Array, a massive global radio observatory, will open new doors. It will have the sensitivity to capture thousands of FRBs per year. This growing network of telescopes is turning FRB research into one of the most exciting frontiers in astronomy. Each detection is not just data. It is a messenger from the far reaches of space, a cosmic whisper, crossing billions of years, arriving at Earth for a fraction of a second. And in that whisper, we may find answers to the deepest questions about our universe. We now reach the last part of our journey into fast radio bursts. We have seen how they were discovered, how they travel across the cosmos, and how they may come from exotic objects like magnetars or cosmic collisions. But beyond their mystery, FRBs are also valuable tools. They help astronomers study the hidden matter between galaxies. They measure cosmic distances. They even test the laws of physics under extreme conditions. Some researchers suggest that by collecting a large enough sample of FRBs, we may map the missing baryonic matter of the universe. This is important because current models show that nearly half of the ordinary matter is still unaccounted for. FRBs may be the key to finding it. And with every new telescope that comes online, we get closer to understanding these powerful signals. Are FRBs the sound of cosmic giants tearing apart? Or are they signatures of something entirely new in physics? That is the excitement. Science is still unfolding. And one thing is clear. Fast radio bursts remind us that the universe still holds mysteries waiting to be solved. All the information we provide comes from verified historical sources, including books, records, and archaeology. Now, before we close, let me share the main sources behind today's episode. Scientific journals, Nature, Science, and Astrophysical Journal letters, research from the KIME FRB collaboration, discoveries by the Parkes Radio, Telescope Australia, observations by ASCOP Australia, NASA and European Space Agency updates on FRB studies. With that, thank you for joining me, Zaid, on this journey of knowledge. Please like, share, and subscribe to our channel, Thrones of Knowledge. Do not forget to press the bell icon so you are notified on time. And in the comments, suggest the next topic you want us to explore so we can continue building the best learning experience together.